Okay.
So, welcome everybody this afternoon, according to Central European Time, on this workshop, which is on ethical and legal issues of artificial intelligence in manufacturing. This is organized by the cluster of European projects on artificial intelligence in manufacturing. I'm John Soldatos, coordinating the STAR project, and later on we have a presentation by Arthur Barnevers in our workshop. So without further ado, I think we have an excellent team of speakers in today's workshop, and we encourage all our participants to engage and ask these top experts questions. Without further ado, I would like to give the floor to Paolo Perillo to say some few words about the logistics, and then go straight to our first speaker, Andrew Adams, from EU-Japan AI project, directly from Japan, being with us today. Paolo, and then please, Andrew, and thank you very much for joining this workshop.
Okay, thanks, John. Some very brief words for the logistic. We are many people today, and I'm helping John on the logistic. I will deactivate the mic for everybody, but you have the possibility to activate it yourself if you want to place questions according to the speaker's preference. The event is recorded, so to allow everybody to have a recording and to take it if you want. So if you agree, stay in the line. Nothing else from my side, John, so the stage is yours again.
Yeah, let's go straight to Andrew. Andrew, thank you for being with us. Feel free to introduce yourself and share your presentation and go on with your talk.
Okay. Thank you, John and Paolo there. So
I guess you just muted yourself, so I can't hear you anymore.
Yes.
Yeah. Okay. I'm unmuted.
Okay. You
and that was Paolo. I think that was Paolo muting everyone.
Yeah. It was
on,
my
on
fault,
a global basis. Yeah. No problem. This happens. It's perils of the technology. Okay. So as mentioned, I'm Dr. Andrew Adams from Meiji University in Tokyo. Unusually, the EU-Japan.ai project has non-EEA or even associate country partners. That's because it is specifically a project aimed at improving the research and innovation and application cooperation between European countries and Japan in the area of AI for manufacturing. And so what I'm going to do today is I'm going to compare the EU and Japanese legal and ethical approaches in this area. So first, I'll just give a bit of a scene setting for how I see the social, legal and ethical issues generally in AI for manufacturing. And in fact, I'm going to start at the level even above that, just what are the issues in AI. Because I want to show you how the EU and Japan have some quite common goals in this area, but are taking somewhat different approaches to how they might achieve those goals. So there are some very interesting potential synergies there, but we've also got to be careful that the different approaches may make collaboration a little more difficult in some of these areas. So I'll talk about common AI standards in general and how the EU and Japan are working on these, working very closely together on these common international standards. Then I'll talk about the EU approach in this area, how they're doing things to achieve their regulatory and social goals, and I'll talk about the Japanese approach, and then finally some conclusions about how easy or difficult it will be to collaborate in this area, given these slightly different approaches. So the social, legal, and ethical issues in AI for manufacturing, as I see them, are part of the general issues that the recent explosion in the applicability of AI techniques, particularly machine learning, but also other AI techniques, has seen. Now, in the general case, things such as the impact of AI on privacy, the fact that a lot of AI applications are based on processing data about individuals, the problems with autonomy, where AI systems can often learn things about individuals that they may not even realize themselves, and may identify our trigger points emotionally or even intellectually, and be able to exploit that either automatically or under the specific direction of people using those systems. This relates to questions of accountability as well. Many of these AI technologies, particularly many machine learning approaches, find it very difficult to give an account of how the decisions are made within the systems. And this gives us great difficulties in holding these systems to account, where we can see negative impacts from their application. And finally, the general issue about whether the people who are able to deploy AI systems are likely to already have great power in the marketplace, in society, and whether those power imbalances will be exacerbated by the ability of governments and large corporations to have access to the data needed and have access to the high computational power sometimes needed to generate these systems, and whether that's going to cause further difficulties in our social balances. Now, when we look at these and see how they apply to the AI for manufacturing area, many of these actually are not so big. Now, almost all of these have some issues that come into when AI is being deployed in manufacturing, but they're not quite so broad. So in the privacy area, well, yeah, for some applications of AI in manufacturing, there are questions about employee privacy. If you are deploying systems which are monitoring activity within your manufacturing facility in order to improve safety or in order to improve productivity, are you just looking at the machines? There is a lot of AI for manufacturing applications which just look at the machines, but they may be monitoring what the people are doing in there as well. And the issue of employee privacy in general in the information age has been becoming a significant area of dispute between employees and employers. So we do still have some privacy issues there. In terms of the autonomy, not often that so much. The autonomy doesn't really come into it in the workplace, really, because as a worker in a workplace, you're not that autonomous anyway. There are still some questions there if we're looking at systems which are designed to motivate employees as to how much you can use AI to analyze their reaction to things. So there's a little bit of that, but it's not such a big issue, whereas it is a big issue of AI in society at large. In the manufacturing field specifically, though, the safety questions are significant. When we were first introducing robots and large machines into manufacturing, there were big questions about employee safety. And over the 20th century, the safety issues in manufacturing were improved. And there are various ways in which that was done. One of those was that in the field of robotics in manufacturing, there were various standard approaches that were taken, things such as encapsulating the areas in which large robots will work, limiting the freedom of movement of the robots, marking those clearly for the people around them so that they didn't wander in to an area of operation of these machines, and having safety cutoff buttons all around the place so that any human who could see that there was a problem could automatically cut these machines off. One of the things we need to do as the control mechanisms for these systems become more integrated and become under the control of an AI is we mustn't lose these safety gains that we've already made. But in some cases, the AI systems will enhance safety. And that's one area where we should be encouraging the use of AI, is to enhance the safety in manufacturing environments. The big one is access to jobs. And I'm actually going to talk about this under the social issue, but it's a sort of ethical and social issue together. Now, the legal issues of AI in general come back partly this question of explainability, also questions of safety in various applications, questions of evidence. When AI is involved in gathering data, how much can we rely on the derived data that is visible to us, and how much do we need access to the raw data? Very often, raw data is very large and is not always kept. So we need to be careful about that in general. And there are questions of liability. Who is liable for the actions of an AI system? Is it the people producing the AI system? Is it the people installing it? Is it the people using it? Is it the people providing the data on which it learns, etc.? Now, again, only some of these are really major issues, I think, for AI for manufacturing. Safety is clearly one of them, and in particular, this liability question when things do go wrong. But also, when things do go wrong, it's not only safety, but it's also the financial impact of things going wrong. Many modern learning systems, you have a basic AI system, then it's trained on your particular set of equipment. So when it goes wrong, how much is it the responsibility of those who provided the base machine learning system? How much of it is the fault of the people using it? And that's a question we're going to have answered really by the courts once these systems are in broad use and we start seeing the issues that are brought up. The broad social issues of AI, we have questions of democracy. The application of AI to the political sphere is a big issue at the moment. Again, questions of autonomy. Anytime AI is deployed in control of people, you have questions of how that's impacting people's autonomy. And I've already mentioned issues about capital. How much are we allowing AI to provide a force multiplier on existing capital? And again, the accountability issue is something that is of grave concern socially. Now, I think the big social issue of AI for manufacturing is the potential for the economic transformation. And this is not just me saying this. This is not just me, primarily an ethicist of technology, but this is economists as well. Now, there are some economists who are saying, oh, this is just the same as every previous level of automation in the economy, and new jobs will emerge to take the place of the ones. And there will be some churn in what the labour market looks like, but it will be transformed. And there will be some winners and losers, but it's down to each individual country to figure out how to help the losers in that transition. There are, however, also a significant number of economists who are saying that actually this is different from previous transformations. We really can't see where the level of jobs are going to come from to deal with this transformation, and the speed with this with which this transformation is happening is also much faster than previous transformations, and that creates, even if we can transform our economies, can we transform them quickly enough to prevent them coming under huge strain and leading to social distress? So how are these issues being dealt with? Well, these are international issues. All of the major economic powers have been looking at this for the last 5 years or so. And the EU and Japan have been key partners together, along with a number of other countries, in drafting these international AI standards. In both countries, there is clearly a focus that AI needs to be used for the social good and also for broad individual good. And that we must avoid the situations that I've been talking about where AI is simply misused by those already rich and powerful people to further enhance their finances and their power. There's a definite concern in both areas to avoid exacerbating inequalities in power and wealth and degrading individuals' autonomy. And there is a concern about unaccountable AI systems becoming faceless arbiters of human concerns. Now, some of these are relevant to the AI for manufacturing area, some not so much. And how are the two different places approaching these in general and in the AI for manufacturing area specifically? Well, the EU approach starts first with hard law. Now, this is because of the structure of the EU. The EU is basically a legal order. It's an unusual sort of body. It's pretty much a unique body in human history. There was no previous body like this. And it's based primarily in hard law. So the EU approach to almost all problems will start with a hard law approach. It does, however, have other levers that it applies, and in particular, the EU is one of the world's largest research funders. So where the research goes and how that research is done and what sorts of goals towards which it's put is also a major lever. The third one is the social issues approach. This is an area where the EU per se does not have that much power. It has some, but not huge amounts. But where the EU is trying to act as an arbiter between the different member states of the EU and try and bring them all together into some common approaches to this, and to enable those with both the research funding and the hard law at the EU level. So their legal approach is primarily with the Trustworthy AI proposal and the Developing AI Act. And with a secondary approach looking specifically at liability and accountability issues. They're not probably going to be in the AI Act specifically. They're going to be later additions, because we still don't know how many of these liability issues are going to be dealt with. Some of the accountability stuff is in the proposed AI Act. Some of it will be dealt with later, either in secondary legislation or in further regulations or directives. On the ethical side, the EU is pushing very hard on accountability based on this trustworthy AI concept. And in the AI for manufacturing area in particular, there's a big focus on the safety of AI as it might be applied in manufacturing. That's one of the areas where the EU has significant competence, is on the safety of workers. On the social side, there's a limited focus of the social issues of AI for M at the EU level. It's seen much more as a member state concern. There is a little bit, but when we look at the funding that they're giving out and we look at the details of the legal approaches, there is either a lack of EU ability to do something in this area, or a lack of willingness to put funding into this sort of area. It's seen much more as a member state concern, with the EU acting, as I said, as an arbiter or a convener for the member states to try and figure out how to jointly deal with this problem, but at a member state level. On the practical level, particularly on the research funding, Horizon 2020, as we see with the ICT 38 cluster and some other calls at the end of the Future Factories theme under Horizon 2020, and this is only going to get bigger in Horizon Europe, which is itself bigger, but this area is a key part of the Horizon Europe research plan. So we're going to see more interest on research funding in this. As they've learned in other areas with Framework 6 and Framework 7, the social, legal and ethical aspects of the research undertaken with EU funding has been becoming more and more important over the years. And again, we see this with the ICT 38 cluster, with it not just being about the technology, but also a lot of this about the social, legal and ethical implications. So that's the EU approach. Here's the counterbalancing the Japanese approach. Now, the Japanese approach generally, and in this specific area, it starts with self-regulation. That's the basic way that Japan works in this sort of industrial regulation area. It does not like having hard law in this area. It likes having self-regulation backed up by government power. Secondly, they do have a significant amount of research funding. It is a large research and innovation investing country, so there is a lot of research funding going into this area. Finally, they are paying some attention to the social context. So Japan as a single jurisdiction, it does have greater direct internal power than the EU, because it is a single jurisdiction. The national government basically has all of the direct power at its disposal. It's, as I say, it's more likely to use it as self-regulation backed up by government's backstops than hard law, but it does have full control over all of these different areas, as much as any government does. It does, however, have less international economic power, and that's, I think, one of the reasons that it's been regularly partnering with the EU, particularly in this area, because there is deep concern in Japan in general about AI, about being caught between the Chinese and American approaches to this, neither of which fit with Japanese social ideals. The corporatist and finance-driven approach of America and the state's overweening power issue in China are both seen as bad ways to do it in Japan, and that's why the close cooperation with the EU in this area. So historically, self-regulation by commercial companies is the way the Japanese government attempts to achieve socially acceptable outcomes. Another area, and this is very specific to the AI for manufacturing, Japan's demographics and their current economics require a different focus. So a lot of the research in this area is on things like robots, but even there, the research funding going into the development of industrial robots and AI for industrial robots is more limited than that in the EU context, because there's less concern about maintaining manual labor in this country, so they've already gone for a lot of robotics. They're also applying those areas differently. There's a great interest in robotics, but mostly in terms of personal care and elder care. That's where a lot of the investment in robotics is going, which shifts away from the AI for manufacturing area. In fact, in the EU Japan AI project, we've been looking at the range of projects funded at both national and EU level within the EU and within Japan. And there is quite a limited amount of the Japanese large amount of investment in AI, but very small amounts of that are being specifically directed to AI for manufacturing. There's much more expectation that the industry will be investing in this themselves. So in conclusions, very quickly, because I'm very close to time here, the EU and Japan share some common goals on AI. In particular, both places stress that they need to provide positive social benefits in all of their areas of application. Divergences in internal approaches, in particular this hard law or self-regulation approach, may lead to different divergent outcomes if they don't seek to work together on common detailed guidelines. They can be put into force in the EU in hard law and in Japan in self-regulation, but we need to have common guidelines. And social differences may lead to different social outcomes, even within those common goals. So thank you very much for your attention. I hope I've helped set the scene for this whole workshop. Unfortunately, it's already almost 10:30 in Japan, so I may not be able to hang around for the entire session and get engaged in the question session at the end. So if anyone has any burning questions they'd like to address to me, please try and do so quickly now. Otherwise, I'll pass over to the organisers and the next speaker.
Thank you very much, Andrew. I think let's see if there are some questions, in the chat, or anybody wants to ask a question. It's most welcome.
I have one, Andrew, if you have time for it.
Yeah.
You talked on the beginning about Europe and Japan being sort of partners in this, and this push toward common AI standards. But then, as you said, in the Japanese side, this is sort of, it seems like less of an issue in Japan because they're going toward self-regulation. So on the one hand, do you think that this push in Europe toward common standards involves or makes a tendency toward these broad sort of principles, at least in ethics, that are sort of weak because they're extremely broad, because you have to get, as we've seen in the global, the COP26 lately, you have to get this broad international consensus sort of principle that comes out of it has to be extremely weak. Now, but that's one side of it. The other side is, since Japan is involved in this self-regulation, as you say, by industry itself, do you get a sense that there are cross-industry standards or internal to industry standards being developed in Japan that are stronger than these broad principles, which are?
Well, the way that typically works in Japan is that the industry wants a level playing field. And so in terms of what self-regulation comes up with, it's a multi-stakeholder process that generates what these regulations come out as. And part of that is the government themselves. Part of that is the industry. And there are, civil society groups involved in these developments of these standards. And there is a tendency to, they're not as strong as they might be, and they're not as strong as in some other countries they might manage to get through hard law, but they're not weak. They're not really weak. It is a strength of the Japanese system that they do have strong self-regulation, and it works. In general, it does work. In particular, it works best when it's a level playing field issue. So it works best when it's to the advantage of business not to be undercut by their competitors by undercutting the ethical standards, and everybody meets them. It works least well when everybody in the industry wants to undercut them and there's no impetus not to. So it depends on the details of which ones. But by partnering with the EU in this area, I do actually think that the common standards, going beyond the top level, as you say, quite limited international agreements, there is continuous work between the EU and Japan and a small number of other countries to go beyond those and to get into the detail of this. So Japan, the EU, Singapore, and a couple of others who were really pushing at the OECD for stronger guidelines, I think are still moving ahead together on figuring out how they can introduce stronger guidelines than this. And it's just that in the EU, there will be hard law. In Japan, there'll be self-regulation. But it will work, I think, quite well in Japan. Apart from anything else, they're very interested in partnering with the EU as one of the world's largest economies in many areas. And the EU-Japan economic cooperation is a priority for both sides. In particular, both sides are very worried about Chinese and American dominance of the world economy and see each other as better partners in many ways than those two other behemoths. Okay.
Andrew, just a very quick question from my side without abusing your time. Since you presented, I think we've seen the differences, right, between the legal approach of Japan and the EU. Maybe each one best suited to the values and the culture of its region. My question is there any way or any thought of actually benchmarking this? Because at the end of the day, we have to see which one is better, right? What we do in Europe, what is done in Japan, or what is done in US. So is there any way to benchmark this from the economic perspective, also from the social perspective? Because even in the EU there are concerns that we are regulating too much and we are making the innovation more difficult.
I mean, I think in terms of the economic benchmarks, the other aspects of the economies, including in Japan, particularly the demographics question, mean that common benchmarking is going to be very difficult to do. I think the benchmark of how well these things are cooperative and equivalent is going to be on how much joint activity there is, how much we see common work done by Japanese and European companies in developing systems and applying systems developed in each country. And that's certainly something that the Japanese want to do. They want to develop systems that are usable in Japan, that are usable in the EU as well as in Japan. And we see this in other areas such as the privacy area. Japan has improved its data protection regime over the last 15 years substantially in order to gain EU third country status for export of personal data. And part of the driver of that was things like the car market, where the car makers, the big Japanese car makers who are international players in manufacturing, were pressuring the government to get EU approval so that they could sell their cars which collect data. which is personal data under EU rules. So they were pressuring the government quite heavily. I was in meetings with Japanese regulators and Japanese politicians about revisions to the Japanese data protection law, at which people from Japanese industry were saying, we need a level playing field and we need to be in coherence with Europe. We need to get European approval. So I think that the self-regulation here will mirror what goes on in the hard law in Europe. And that's one reason why there is such political cooperation on making sure that these proposals are equivalent. And then the mechanism for implementing them may be different, but hopefully the outcomes will be close enough that we can work together.
I don't know if you can take one more question from Raphael, right? Because
Yep.
Again, thank you for staying the course, and thank you so much for the time. Raphael?
Yes, thank you. I have one quick question, I hope. Can we say that social issues are not that important to Japan than protecting the business?
Oh no, in Japan, I mean, this whole area of AI sits within a major government policy area called Society 5.0, which was first issued in 2016 in Japan and has just seen its second iteration. And the whole area of Society 5.0 is about making sure that the information society in all its different areas works for the citizen and works for society and doesn't just work in the service of big capital and big data. So this is part of a broader focus here on making sure that this isn't something which destroys the fabric of society here. So yeah, I wouldn't agree with that statement at all, I'm afraid.
Thank you very much, Andrew.
Thank
you very much. Much appreciated.
Thank you.
In the course. So let's move to our next speaker, Mark Adelson. Mark, feel free to introduce yourself, your project, and go on with the talk.
Thank you, John. Just a second. Do you see my screen?
Yes, very good. Very well.
Okay, should be good. All right, so thank you very much for the organizers for having us in this workshop. It's going to prove it's going to be very interesting. It already is interesting. My colleague, Dr. Karen Fowle, couldn't be here today. She has classes, unfortunately. She's an AI ethics specialist, and for many years already, she's been a member of multiple AI ethics committees and working on AI ethics. And I myself am a researcher, postdoc, hired by the AI Proficient Project, going on the second year now, a philosopher by training, research in AI ethics and ethics as value applied to products and manufacturing, and author of a 2019 book, Hyperthematics, The Logic of Value, which explores some of these things. Right, so one of our interests in AI Proficient is the concept of human in the loop. Human in the loop and human on the loop and human in command were terms that were integrated into AI Proficient, the project, from the beginning. And in use cases proposed by the manufacturing partners, they were requested. Human involvement was requested under these terms from the beginning. So for example, for one partner, out of 10 use cases proposed, 8 were requested to be human in command, 1 was requested to be human in the loop, and another was requested to be human in command or human in the loop. But what we've found in the project, in the use cases, is that there's often ambiguity in the use of these terms. And a few examples are that human in command is requested, but human is specified, but the degree of command of the human is quite unclear. Or to take another case, maybe human in command, but no one is actually specified as who will be the human in command. So there's a deeper potential problem with these terms gathered around human in the loop. And the EU Commission, the Guidelines for Trustworthy AI of 2019, tries to give an overall definition which defines all of these under a certain notion of human oversight. right? And for human in command, for one of them at least, this is a very broad notion, and it can include, for example, using the AI in different ways, but also not using it in particular situations. And so the kind of problems which arise in our project, and I'm sure in industry generally in this sense, are problems, for example, of there being work hierarchy. The lower level worker has to take commands, orders from the managers, the upper level. And now this segs into issues of responsibility. Someone's in command, but who's really in command if someone has to take instructions from someone else, right? There's also issues of lack of knowledge in terms of explainability. How much are you in command if you don't really know what's going on? And there are also issues of mismatch between human and what we'll call machine or AI stamina. The AI just goes and goes and goes, right? The machine does. The human doesn't have that kind of energy, let's say. So there's some ambiguity in using this term in human in the loop in our project. Our ethics method in AI Proficient has been to give very specific recommendations, which we add to and which we evolve over time. And so far, over the last more than a year now, we've given about 90 specific recommendations over 8 of the use cases. And I have an example there, an anonymized use case. So this is in terms of human in command. And so what we suggest, for example, in this context is that the default position about whether operator X is always expected to follow an AI proposal should be specified clearly, either overall or for different phases. And in fact, we recommend a trial period for that use case, that part of that use case. So for so many months, the operator will consult AI proposals, but use their judgment. And for another period later, the operator must always use AI proposals unless some major thing. So in other words, specific recommendation to formally clarify what this in command means over the AI. But this is not enough when you start to think about it. And we did, of course. It's a stopgap measure, even though the recommendations are specific. It's the terms themselves that cause some problem. And so we started looking back into the history of these terms. Where did they come from? How did they evolve and so on? So the first recorded mention of human in the loop occurs in 1958, Birmingham, in a military context, in terms of humans involved in missile fire control systems. And with Birmingham and others of the time, slightly later, these are psychological studies. And the original human in the loop meaning was something like human as component of a control system. And what Birmingham says, essentially, is that humans are too variable. They're too adaptable, right? They're clever. And so if you have a poor system design, what they'll do is they'll adapt themselves to compensate for it. And so this messes up the idea of human as component, which is what is desired when we say human in the loop, for Birmingham at least. And so he says humans should be replaced as a component unless they're more efficient than alternative components. And this usually means more efficient in a cost-effective sense, or in those days, the size of the components, and if they're also needed as safety monitors. So from the beginning then of these terms, you get this tension between human as component and human as an overseer or monitor of the system. The term human on the loop, the earliest reference we could locate comes from 2000 in McLaughlin. And again, the human here is viewed as a component of control systems. But later on, in other works, in other references, the term is used to indicate humans monitoring algorithms, for example, in drone missions, or even actively guiding automated planners for military missions. Human out of the loop, not specifically used in our project in AI Proficient, but still one of these basket of terms that comes from and is related to human in the loop. And for this one, the earliest located references were in 1988 that we could find in Sanders, and military references. And the human is again entirely removed from the control system, supposedly. But again, later in, I think it was 2011, in the context of ship navigation, the term is used for the human being partly removed. In other words, oh yes, the human is out of the loop, but if some disaster or some emergency happens, the human could jump back in. So is the human out or isn't the human out? That's the question. Human in command. This one is very recent. It's not recent in the sense, it's recent in this technological sense. It's been used extensively in military context, but as a technology-related term, it's much more recent. Or we could find some non-published EU references in the media as early as 2017. But then it was developed by the EU Commission Ethics Guidelines for high-level guidelines in 2019 for trustworthy AI. And so, as I noted before, it refers to this very broad capability to oversee the overall activity in economic, societal, legal, ethical impacts, and the decision to use or not to use the system. So extremely broad. So essentially, what we discovered was that there are a mess of meanings, a wide variety of meanings, and to just focus on human in the loop, which is the primary term, is being used to mean the component of a system, the human as component of a system, the human as monitor of a system. It's been used to mean a simulation, the simulation itself involving real-time human action. It's been used to mean human involvement at all in a system. It's a very blanket term. It's been used from the mid-90s, I think 93 or something, as early as we could find, in the sense of training an algorithm, and it's been used in others. And we sort of made a summary and gathered together the different meanings. And in fact, the other terms, they don't have as many meanings as human in the loop, but each of them, except for human in command, has 3 or 4 different meanings, has had at least. So as I said, high-level expert guidelines on trustworthy AI try to gather them together in the notion, under the notion of oversight. But oversight, as I noted, was not the original meaning of the terms, and it also abandoned some of the many other meanings. And so this notion, which is now preeminent, of human as overseer, has always been in tension with human as component, that notion from the beginning. And for us, it comes out, it can be said something like this: insofar as human roles can be taken over by automation or AI in the specific case, then the human is being viewed as a component, back as far as Birmingham. But insofar as automation or AI hasn't yet impinged or encroached upon more complex human capacities, then the human is viewed as an overseer. The human is outside sort of the system at that point. Now, for us, there are ethical implications to this. This is, for us, a negative conception of human participation. Humans are measured by how dispensable they are. Insofar as you can get rid of humans, you don't need oversight. But when humans are, so far as the AI cannot yet do certain kinds of things in a trustworthy way, you still need humans. But the goal then, the push, the tendency is getting rid of humans, which is, well, we're in an ethics, presumably, for humans, so it's inconsistent. It's a sort of a dynamic, contrary tendency with that notion of an ethics for humans. Mahaley Heather, in a 2020 article, puts it something like this, I paraphrase: our wish for AIs to have autonomous control is paradoxically opposed to our wish for control of the AI in terms of unwanted consequences which we nonetheless cannot foresee. And for us, this has been very visible in talking to some of the process engineers of the AI Proficient project use cases. On the one hand, AI is out there as this, wow, this is something that could really help us. On the other hand, they stand back and say, wait a minute, I don't want to relinquish control to this thing because I'm not sure what kind of problem it could cause, right? So you have this tension there. And besides this, Ben Green has written very thoroughly in a 2021 article showing that there's quantitative research showing that oversight in related areas, for example, government use of algorithms, doesn't work. It really doesn't work. And we have to have a reworking of this notion and this concept. So our way of moving forward is to suggest something like this. New terms. We transform oversight into actively guiding ourselves as a community of humans engaged in technology producing actions. Human as component, we transform into being included actively as a member of the community of humans engaged in technology producing actions. And out of this transformation, we suggest we develop a positive scale where we rate human implication in the technology community, not human oversight. Instead of human overseeing some sort of distinct object, which is the AI, and getting continually farther away because the AI presumably advances, gets more complex, and takes over more and more human tasks, we say something like, okay, include the human in the process and rate that inclusion as an alternative to these kinds of terms. What we call this is IGP rating. For example, IGP 111 with a subscript. And we use it under three terms: inclusion, guidance, and persistence. And one being the lowest level and three being the highest level. Now, this is not exact, but something like this is what we suggest, that at the lowest level, for example, for inclusion, the human is viewed as replaceable by any other human. Anybody can do that, right? For guidance, at the lowest level, the human's use of the system is merely register, is a passive use. For persistence, at the lowest level, the human's involvement is brief. The human initiates or contributes to some part, some abstract phase of that technology project, that community. But at the higher level, at the highest level, let's say at level 3, for inclusion, then the technology community develops technology around the unique skills and context of someone, like someone with a name and a face. At the level of guidance, at the third level, third degree, then we have human as designing, actively participating to design complex parts of the system with others. And under persistence, at the third level, we have evolving contribution, where the human contributes to the process of technology community as it overlaps and moves into new and different projects and beyond just the project that it's in. So to give an example of using this scale in AI Proficient in a generalization of one of our use cases, let's say your goal, your project is stabilize a problematic chemical reaction with AI. The community is, various. The community is made up of console operators, digital twin developers, algorithm developers, process engineers, ethics specialists, and so forth. How would we rate, for example, the console operator IGP? Well, under inclusion, let's say at the beginning, at least, of the use case, start of the project, the operator is viewed as replaceable by other operators. Under guidance, you might rate a 2, right? Mid rating, the developers will try to make use of operator feedback, suggestions of the operator. Under persistence, the operator might rate a 1. The operator will implement AI recommendations eventually, but only after design and testing phases. And at the beginning and at the ongoing of the process, the operator is sort of shut out and doesn't know and doesn't participate. Thus, at that point, we would have something like IGP 121. Could we raise it? Could we raise this then? Well, could we raise it to IGP 232? In terms of inclusion, for example, could the process engineers and developers draw upon particular skills, interests of that individual operator For example, in the explainable AI aspect of the algorithms, could it be tailored to that particular operator's experience and skills? Under guidance, could the operators help to guide directly the development of these solutions, which is what they are, directly working with the developers in, for example, tailoring XAI or in formulating sub-phases of the solution, right? You draw on the operator helps with their experience to say, okay, we should come at it here first because, well, I know this about the system, and then we should go to here, and then we should try this. Under persistence, could we get the operator input and guidance from the beginning of the process? For example, in the digital twin phase, and could we keep them informed through the whole length of the process, right? This is what we're doing, this is what we're trying, and so on. This is the goal we hope to get in the solution. So with these terms, what we hope is that oversight can still be captured in the scale for technical uses, but the oversight would have degrees, and degrees which mean something for ethical implications, more than simply saying, oh, there's a human in command. Well, what does that mean? And so, for example, the top level, IGP 333, you would have true oversight, participative oversight, while IGP 111 will be a very weak oversight, even you might say illusory oversight, to the level of, a kill switch, a button. You can stop the system, sure, in that sense, but does that mean you're in command because you can press a button and stop the system? We don't think so. So these are our suggestions, our sort of scale that we've worked up to give it more, get more into it in the ethical sense, get more meat on it. Thank you very much.
Thank you, Mark. Let's see if there are any questions in the chat. I think we saw a very interesting approach, right? That actually makes things work, right, in practice, and assigns weights and factors and so on. If there are no questions in the chat, maybe we could move to the next talk. Raphael, maybe it's your turn. Please free to introduce yourself, introduce your project.
Thank you. One moment. I will try to turn on my screen. Okay, I think, okay, I see that everything is working, right? Thank you.
Yes, we can see your slides. Thank you.
Yes. Thank you. My name is Rafael. I'm from Soldatos University, and today I want to try to highlight a very interesting subject that we do not pay attention to it, to collecting the data for legal issue. And first of all, I want to ask all participants the question. You can answer by using this QR code and this code. Why do we need the lawyers for manufacturing purpose? How they can help us? So please, if you have the phone, if you have the possibilities to answer, you can do it. You'll see the answers. While we are waiting for the answers, I also want to add that I am working with Dr. Gabriela Bauer and Professor Jagielska on Soldatos University on Math for AI project, and we are there for monitoring the legal stuff. And my today's subject is connected with the collecting the data that is not protected by GDPR, that is not confidential, but we can use it for some other legal issue. Okay, so I see some answer, but it is the name. So maybe I will try to help our participants and change change the presentation back to PowerPoint. I identify 3 fields when we need a lawyer for manufacturing process. The first is, what I said, we need the lawyers that know GDPR because we need to protect some data, personal data, but we also need this lawyer who know the cyber things because, for example, we need the data to make the business continuity plan. We also need lawyers because if you are talking about the manufacturing is connected with some place, with some building. So we will deal with some governance, and this governance is going to control the impact of manufacturing to society, to environment, etc. So we need some lawyers to prepare the documents for them, and we also need the lawyers to prepare the contracts. And there are some examples of contracts. For example, we need to have employers, we need to make some, to buy something, some materials for manufacturing for purpose. So we also need the lawyers to have access to such data, because if they have the access to the contract stuff, they can, for example, make better contracts and help us to minimize the problem of some dispute. So these are the 3 fields. Let's see if there are some more answers. No, nobody answered the question. Okay, so I think I can go to the next slide. So if we are talking about the legal intelligence, there is also the gap in most projects. I say that when we are talking about collecting the data, we never think about analyze the legal risks and collect the data that could be used for some legal purpose. And there are 3 gaps that I think that need to be discussed if we are making manufacturing and we want to use artificial intelligence. We are going to use some new technologies. And there will be there will be some regulation. There always will be some law because there always will be some government. So we will always deal with demand gap, algorithm gap, and data gap, because these are the gaps that is very hard to discuss with the lawyers, and sometimes engineers not pay the attention to focus on the gap, that to think that this data can be used for some legal issue. And of course, for example, the great thing is to show that sometimes there are some solutions adapted to our systems that we use, for example, in manufacturing factories. For example, in Poland, there was a Waste Act. I think this was in most countries in United European. So it was necessary to make this system to prepare all the documents based on the layout to make sure that the organization who is dealing with manufacturing could prepare the documents and send them to the government organization. Also, there are some examples, mostly at big techs, where they're trying to deal with the contract, with data from the contract. So why do you not do the same thing with manufacturing? To give the legal department, give the legal access to the data from the contract, they make the contract better. Looking at the solution, I think that we need to always think about the 3 ways. First of all, we need to analyze what data is relevant. Then we need to think about project collection and processing, because sometimes, for example, this data will not only be a data to put to the layout document, but it will be some kind of evidence. So we need to collect this data in a proper way, to use it, use it for some kind of legal issue if we want to make some code, for example, believe us. Then we have efficient operation in accordance with the rules. Of course, we need to make this manufacturing process good for example, our neighbors, because there are some rules, for example, the rules that are giving us a kind of numbers for the noise. And if we are having some neighbors, we need to remember that we can't make our manufacturing process louder, because then there will be problems with the neighbors. So we can also use and think about using artificial intelligence in manufacturing to collect this data, to know the rules for using this data in the future. Of course, I'm not talking about replacing the lawyers. I'm talking about helping the lawyers to make the legal department more efficiency, to make them work only on the most important things, for example, in contracts, not to deal, for example, with the document stuff when we all need only the data to pick this data and use this document. And of course, my question is, what could go wrong if we want to make these gaps disappear, if we want to give the lawyers the access to the data, if we want to make artificial intelligence to help the lawyers to collect the data from manufacturing process and then to send this data to the legal departments, to the lawyers to use it. What could go wrong? If you have the phones, I'm very curious about your answers. About what do you think, what could go wrong? Because I see that we are having a participant. Okay, do you hear me? I see there is a problem.
Yes, Rafa, we can hear you, but it's kind of, not very clear, I would say. So we can hear everything, but maybe you can improve the quality.
Your audio is breaking sometimes. That's the problem. Or maybe you need a better connection, right?
Okay, so moment, I will try to change my microphone.
Okay, take a minute, because the quality of audio was not very good. So.
Okay. Sorry. I didn't see the problem before. Moment.
And it's not because of the Murphy's law. I think it is.
Okay. So now it's better.
Much better in my ears.
Great.
Yeah, it's much better, definitely.
Okay, that's great. So I will maybe go back to the previous slides. As I said, I will try to repeat. There are some ways to help the legal departments, the legals, to use the data. If we are now discussing about using artificial intelligence manufacturing, if we have the possibility to build this on a better way than we see it now, then we also should remember to give the possibility for the legals to access the data from manufacturing, because it will help us to build the better organization. And if we can collect the data, of course, as I said, the appropriate way, if we can use artificial intelligence to help the legals to use this data, to make better contracts, to prepare the evidence if we are going to deal with some dispute, then we can say that we achieved the goal, that we have artificial lawyer, and we can make this manufacturing process better. So I was also having here the questions for participants. I will check if there are some answers, but I don't see any answers. So maybe I think there could be some questions at the end. So this is all I prepared to show this subject, because I think that we do not discuss about it. 2 years ago, I was having him on a global legal hackathon, and we were thinking about helping the businessmen with the Waste Act, and we prepared the chatbot that was collecting the data. But after then, we realized that it is not the way to do this, because it should be this kind of collecting data and using it for the legal issue should be in the system. So if we are talking about artificial intelligence in manufacturing, why not to use artificial intelligence? Thank you.
Thank you for fixing the connection. It was much better in the end. Of course, I think we slightly missed some of the beginning. Let's see if there are any questions. Otherwise, we would like to thank Rafael for the concept of AI lawyer and move to Arthur.
Hi, everybody. It's Arthur.
Please feel free to introduce yourself and your project and take the time for your presentation. Thank you.
Thanks, John. Thanks, John. Thanks, everybody. And thanks for the previous speakers. Very interesting to hear different perspectives in the projects. I'm a lawyer, not artificial. I use HI, which is human intelligence, and I add indeed data and digital capabilities to it. And I'm part of the STAR project. So the STAR project is about trustworthy and secure AI. Of course, in manufacturing, we have about 10 use cases in the project, all related to the interaction between human and AI and robotics. And my presentation is about AI that works. And I already heard a colleague from Tokyo talking about it needs to work for citizens, it needs to work for people, it needs to work for society. And that's indeed what I want to talk about. So it's about the symbiosis of the functions and the features of AI and all the system around it, the technical digital system around it, combined with non-functionals. We are in the team here at Arthurs Legal, based in Amsterdam, with multiple people that are working in the projects, not only me. I'm not going through the words and the names, but some of my colleagues are in this call today, actually. And of course, looking forward to, in the cluster, to talk and work with you in the next few years. Lots to talk about, lots to work on, so looking forward to that. Where the colleague from Tokyo talked about the Japanese Society 5.0, I talk about the European perspective here and the work program of 2021 and actually 2022 and beyond by von der Leyen from the European Commission. Basically 3 pillars, more green, more digital, more resilient. And resilient is both infrastructural, society, people. I mean, the word resilient, of course, is quite versatile. And it's not just to talk about those 3, it's trying to resolve certain societal challenges. And for that, I use the societal challenges methodology by the Future of Living Institute. And in this case, I will be focusing on people, either on the working floor or helping out with insurance, either before or after in the project manufacturing or assembly, but also, of course, at other places in this very important sector. You see, that's not only one societal challenge, but there are multiple. I will talk about demography, same as in Japan and some other countries. There is a shrinking demography with less working people, and we need to do more work with less people. That's one of the things. Of course, we want to make sure that people stay healthy long and don't need to do the heavy work, so they also able to be productive for a longer time. Inclusion, I think I don't need to explain that, not only digital and financial, but also social, also on the working floor, also related to AI and robotics and other systems. The resilience part I already mentioned a little bit. Safety and security, well, STAR, the S is for safety. So that is for sure part of it. And it's, of course, both physical safety as well as cyber physical safety, and also, of course, cyber safety and security. Last but not least, skills and jobs. We need to basically try to reinvent ourselves, reskill, upskill. There's a war for talent going on already for a while. It is increasing now. Secondly, we have brain drains to other places where youth and other potential of a country or member states leave the country, and they may never come back if there's no opportunity for them to work. So we do have some big challenges in Europe, but these, of course, are not necessarily European. These happen in other places as well. This is just to show that everything is intertwined. These societies are not standalone, so we need to have a holistic approach. And of course, while being holistic, also try to untangle and unbox the problems and try to, like the previous speaker did quite well, try to figure out exactly, and also the before regarding, what is human in the loop, what does it mean exactly, so we are on the same page. We, of course, have modern 21st century capabilities available, AI systems, robotics, IoT, cyber physical systems, data, of course, very important tool to work with. It's an asset, it's a means, and of course, we need to balance that out with the non-functionals, privacy, security, safety, and all kind of other accountability. I heard already, very important, and of course, sustainability as well. Also, economic sustainability, because otherwise it's philanthropy, and that's all nice in the projects that it gets paid by, European Commission and the member states and others. But it's all about what can we do after? What is the end product of a project? And it's not mere funding. Of course, Star can play, and of course, I think the other projects, I will looking forward to the other presentations after, can play a big role in that. On the other hand, and of course, I do see some engineers or engineering background people in the audience, so there's no bashing possible now. But of course, there's a tendency to focus on engineering, have a technological approach, trying to figure out what is the balance between, the algorithm, how much data do I need to learn it or to make it smarter? Do I want to get rid of the people? Do I want to make more profit? Do I want to make it more fun for people? Do I want a double loop system where the machine learns from the colleague in the cobalt situation, which is one of our use cases at Star? And then, of course, the cobalt also loops back and gives feedback how the person is doing, let's say, at 5 o'clock when the sugar level in the evening or the afternoon may be a bit lower than in the morning. So this all looks quite nice, and we can, of course, do in a standalone mode, a standalone robot, standalone system. We can start connecting it to the internet or another system, and then, of course, interconnecting like independent robots talking with a decentralized system. And hyper connectivity means basically the far edge where the systems talk with each other, and then definitely human in the loop becomes even more important here, especially as we want to keep indeed the people having a very important part and definitely have at least meaningful control over the systems. So then, generally people think, okay, we have a nice tech stack, we have data, we have a methodology, of a business model, so let's go. And then, of course, I ask, and others I think in the call as well that I see, would generally ask, what if it doesn't work? And then generally you get an answer, well, we just fix it and we repair it and we move on. But of course, then, you probably get banned or you get a cease and desist, or you need to stop with, you get a recall or whatever, or the whole factory floor stops because of the authorities that need to step in. And whether there's law or not, that is ethics, they will definitely step in. Not based on new regulation, but based on existing regulation, employment law, social safety laws, and other safety regulations. They will definitely use that. On ethics, I just wanted to show that ethics is a very popular term. It's almost a hype term. It's at least trending. But there's much more to the equation. Everybody has his own ethical framework, and it changes contextually depending on who you are or which side. If I'm here in Amsterdam on the bike, I don't necessarily like cars. If I'm in the car, I don't necessarily like bikes. That is my own ethical framework. But of course, it's about how I behave, and then whether I have certain responsibilities, either written or unwritten. There is ethics, the unwritten part, the uncodified part, at least on the continent. But the fact that it's not forbidden by law doesn't mean I'm allowed to, and I have my own responsibility to do that, and that's what we call accountability. And of course, we want to avoid going to the worst part, liability, and remedies and damages, and that you need lawyers and whatever, and your reputation goes down the drain. This is one of those elements we're going to plot and map at the Star AI Pro. Sometimes in these slides show where we definitely going to take it in and plot it and as well. So this is basically what I mentioned, how to make it work, focusing and balancing out on both the functionals and the non-functionals, not seeing non-functionals as a problem. They are definitely not. They are an enabler. They build up trust. They build trustworthiness. They can help in making actually it very enticing, attractive for people to start working in a company and organization that use these kind of systems, and therefore you have a competitive advantage over people that don't care too much about safety or about involving and the inclusiveness of people on the working floor or in the office. So I think it's a huge business opportunity to take care of, and that doesn't necessarily need to be an inhibitor. I think it's the other way around, as you can hear. I already heard a little bit about soft regulation, hard regulation, and self-regulatory. This is a framework we use already for a while, where we just want to highlight a couple of attributes. You see law and regulation. That's the hard law. There are all kind of different layers, by the way, in regulation. There can also be an incentivizing regulation, not only the stick, but there can also be a carrot in there. Official policies are quite important. These are basically fine-graining particular regulations or laws. And of course, case law, we don't want to get there, but these are there in this domain that you and I are working on in manufacturing are there. Employment law, liability cases, injury, death by a rogue robot that we unfortunately know the cases, and sometimes there's also case law. The other layer on top is maybe not that hard, but still it can be mandatory standards are there as well, especially in this domain where humans are involved, the soft targets are involved, and then especially in Europe, these are always in the equation. So you see a different set of instruments that can be available and that are available, and we need to balance out per use case, per context. And of course, those contexts in a pilot, we can try to get to a couple of abstract level higher in the way that we can also start, disseminating that so it can be reused, it can be optimized, it can be bashed, it can be, challenged and improved. Another thing we're going to plot. I already heard about human in the loop and who is in control. Well, I think in quite a lot of cases, it's not one organization or one person. It's probably multiple. It actually would be good in certain cases that there are multiple places in the loop, like the Works Council, the union, because one employee may not have the power or the voice to speak up and except he can speak or he or she can speak up and get fired. But of course, many others on the business side, on the engineering side, on the regulatory side. And of course, the customer partner side, there are multiple influencers here, and what I call the spheres of influence and the spheres of influences. And per use case, we need to plot, who is involved, what do we need to take into account, who should we, make sure that if something goes wrong, that we, are there on time, that we can improve things, or how can we avoid that things go wrong. And we need a lot of stakeholders for that. One of the main principles here is stop pointing fingers. We always love to point fingers to the other. And when you talk about control, I have a simple notion for you. As soon as you point fingers to the other, you have lost control over the case and over the problem. Because then you basically defer the issue to the other side. Is not your problem. Pushing it away does not solve it. And you hear this from an attorney at law who is already attorney for more than 20 years. A little bit about risk. I think and risk classification, we sort of think of risk as a four-letter word. A little bit, I think it's underexposed. It's not too much on the radar. We need to really dive into it way better because generally we say, yeah, there's risk, and then we move on further, or we try to, contract it out, saying we're not liable, there's no warranty or whatever. And just that doesn't cut it. We need to get real fine-grained, and I think in this group today we could do that. If you look at the risk classification, in this case of a OT, IT, IoT system, depending on what kind of machine is involved or an AI system that is involved, then you could have a risk, as we call it, a risk spectra approach. This is one risk spectrum. What kind of risk classification does, for instance, have the particular connector? Could be a sensor that's figuring out where a person is. And then, of course, that may indicate, or that brings in the indicators and the smartness on try to predict where that particular individual is moving to. So that is one risk spectrum, but there are many others. The functionality. I can't do them all in this small time slot. But there are multiple risk spectra that you each of them need to focus on and add on top of each other to figure out what exactly is the risk. that we're talking about, and how can we cater, how can we avoid as much as possible, how can we mitigate risk, how can we avoid problems, and how can we avoid unnecessary, unwelcome surprises. Another angle that we are focusing on, will be focusing on, and are focusing on, is the lifecycle approach. It can be perfect today, even though perfect may not exist. And tomorrow, or one patch, one update later, or there's different data coming in, or the data is not, at the right level. It's coming, it has been compromised or whatever, or it's just poor data. The system has been changed, updated. A particular component has been included. There are other stakeholders involved. You're at a little later phase in the legal life cycle. Where you are, let's say, the end of a legal relationship with your contractor, and there's less of a love relationship between vendor supplier. So there are quite a lot of life cycles that we all need to take in. That is all perspectives that we need to focus on. So this is the initial call on this cluster in ethics. So I love to make it more complex, but I think you can handle it because you're all experts on this. Couple more very quickly. Generally, we focus on process and technology, and then we have, in this case, employees, a people, society in the middle. But of course, with AI and data and digital, there we need to have a different look. We need to have people, process, technology, and data. And data is not a four-letter word. It can be structured data. It can be, learning. So like the knowledge part, or the experience that you can put back into the knowledge, and with that you can, both improve the knowledge level, intelligence of the staff, as well as of the cobots or other AI capabilities that are, working along and together with in some kind of balance or not. It can be 99% autonomous, 1% person, or the other way around. And this is what we need to balance out as well. As I mentioned a couple more, this is the data life cycle. Not going to explain it too much, perhaps we can talk about it later. But you will, it may collect data like, with sensors. It can also create data, metadata, derived data, those kind of things. Of course, it needs to in some kind of a mix be used. It may be stored or not, depending on whether you're allowed to, whether you think it makes sense, whether there's IP or trade secrets in there. Of course, less personal data. And perhaps we want to share it with other systems, or want to in other ways. And of course, at the end of the day, certain data you may want to delete, especially personal data. If there's no legal grounds, you need to delete it. So here again, it's a mix of mandatory, voluntary, opportunity, focus on the mission, try to address societal challenges, and try to make it fun, basically, for people to work there and to keep them in, to entice them in, to raise the trust. And to become an attractive employee. Another one, and I'm almost there, is what we call the co-creation cycle of success, where we start again with functionalities and features, and then we need to loop around clockwise, sometimes a couple of times, in getting all these perspectives involved. And there are not many, or almost none, no individuals that can do them all. You need to have different perspectives, different people, different backgrounds, different gender, to make sure that we get somewhere at the end of this clockwise. So let's say at 11 o'clock here, sustainability means, is it affordable? Is it ecologically sustainable? Is it economically sustainable and feasible? And if not, you loop it around again until you balance out all the rights, obligations, but also the affordability and the durability of the AI system. So you need a lot of people, interdisciplinary, not only lawyers, not only engineers, but the whole lot. And that's what we are going to plot also per use case. Then again, I mentioned already life cycle. I think this one makes a lot of sense. On the top you see design, sourcing, production, integration, you move on. And of course it goes both for the manufacturing floor, but also, so where are you using the AI system? That's context. But of course the system itself also will be upgraded, maintained, and those are the scary moments that you try to update those kind of things, because you don't actually know, or you may not know what it means, and you want to put it in production immediately. Well, probably you first want to test it, try it, and sandbox it before you do. at the end of the day, as I mentioned, what we're trying to get at, I think, with most of the AI and manufacturing pilots that we have, and I want to come up with a set of technical measures, a set of organizational measures, combine those, and of course, trying to visualize it, make them actionable, deployable, where possible, document them so later on you can also, augment it better. And one of the goals may be to, as you can already see for half a minute, what kind of skills we can cater for that the youngsters and new generations are looking for, and what in this case World Economic Forum, but also OECD and others have the same lists. What we are waiting for, society is waiting for, economy is waiting for, but also what the new cohorts of people would love to contribute to. A little promotion as my last point. John is a little book. It's out now. It's a publication. John is one of the editors. As you can see, it's a bit fuzzy, the picture. And in chapter 11, we have a chapter about ethics. It's online available already. I just checked, more than 1,715 downloads already in 2 days. Sorry. So it's free of charge to do the download. There's also a printed version available. But I think it's quite nice that already a publication has been done. And then my last personal thing, I'm not saying that STAR is aiming for that, but I sort of am. We're aiming for multiplicity. I don't know whether you know the term. It's beyond a singularity. It's multiplicity. It's a symbiotic combination of diverse groups of people working together with diverse groups of machines, data, algorithms, and of course, therewith also with AI. To identify problems, address them, try to solve them, challenge each other, and make decisions on a meaningful and accountable control. And perhaps now it's too early, even execute them and monitor. So I hope it's food for thought, and looking forward to the presentation. So it's back to you, John. Thank you.
Thank you very much, Arthur, for this great talk. I think we have audience which is still around, so we haven't missed anybody, but not asking questions. At least it's good that everybody is here. So I don't know if we have any questions on the chat for Arthur. By the way, what I'm going to do is I'm going to share the link of the book on the chat so that it is easy for you to download and, of course, read Arthur's chapter 11, which is relevant also to the presentation. Yes, great. I think somebody from the audience was so kind to share the link before I do, so I don't have to sell the book. It's anyway free to download, open access. So thank you very much, Arthur.
And looking forward to, of course, comments and feedback about the chapters. Right, the book is just a book, so it's a start of a conversation.
Exactly. Thank you very much. So maybe we can move on to the next speaker, right? To Assistant Project Benedict. Please feel free to introduce yourself and your project, and go on with your talk.
Yes, so you should be able to hear me and see my screen, I guess. If there are some audio issues occurring, please interrupt during the presentation because I'm not monitoring the chat, so please unmute yourself and just step in. So what I'm going to present is also, I would like to link into the presentation before as kind of a starter for a conversation. How we, and we means the Europa University, Viadrina, and the European Youth School are within the assistant project that was also introduced in the last kind of these workshops, how we are developing this, what we call a human-centric architecture. So let me see if I can click next perfectly. So I will quickly tell about where we come from, and then I will tell you a bit about what this developing a human-centric architecture actually means for us. We'll also mention some of the art principles as they are kind of the foundation for the concrete work we're doing. And I will also, as it was announced in in the agenda also as experiences and reflections, provide you with some critical thinking that we had so far about the work we're doing, and this might also be a starter for the conversation, the questions afterwards. I see there is something in the chat that I can't see. Okay, just somebody has to leave, so goodbye. So where do we come from? What we've heard today is that there's a bunch of frameworks and stuff out there. For example, the trustworthy guidelines were mentioned. There is this high-level expert group on artificial intelligence. There are multiple approaches out there that tell us how we can responsibly and human-centric design artificial intelligence. So these calls for the need of them are out there. They cannot be overheard, kind of. But the challenge that we are actually facing is, how do we translate these abstract values and these abstract principles into the very concrete practices in the development process? So in the end, there's an engineer or somebody writing some code, and they have to like physically write code. How do we bridge this gap between what we agree on in an abstract sense to this very concrete lines of codes or two very concrete data sets? And the issue was framed, for example, by Hagendorf as these rather abstract approaches are hardly translated into concrete results as they are not put into practice. There are kind of two different approaches, and what is interesting about the Assistant project is that we are also combining these two approaches within the project. So we have this work package 2, in which we have, as you can see, both kind of approaches present. So one of them is rather focusing on the result, and therefore kind of examining and ensuring that in the end, the products that we're building, namely a digital twin for manufacturing optimization using AI tools, is actually in line with trustworthy AI guidelines and with all these other recommendations that are out there. But there's the other focus, and this is the one I want to talk about now, which is the focus on the process. One of these approaches are principles that I will also introduce to you, as I promised before. But what you can see here is that we have kind of two different levels within Assistant that we're trying to address. So there's this high level, as we call it, approach that is mostly looking at, for example, the architecture, the interrelation of different components, and rather overarching questions of responsibility, of how do we collaborate, how do we actually gather requirements, and so on and so forth. And there's this rather low level perspective towards for example, concrete algorithms, concrete data sets. So we have this kind of distinction, and we think it's interesting to develop both of these processes next to each other, and also have, of course, this is what also is happening in the work package 2, some kind of exchange between these different approaches, and also to try to, in the end, come together. So we are kind of responsible for this process-oriented perspective, and we are doing this by something that we call human-centric architecture. So as an every technology development project, we are basically supposing an architecture, but the architecture that we are proposing or developing together with all the other partners in the project is not just a technical architecture, but is instead a human-centric architecture. I would like to also specify again what human-centric means. It basically means that the interfaces of the machine with the humans, or these interfaces where machines are interacting with humans, like are specific in the focus of what we observe. And this is not too mixed up with human-centered. That is rather also a term coming from product design, where it's about including humans in the design process to ensure that the projects you actually build are built for those humans. So you don't build something that actually don't have any requirements. So we are explicitly looking also at this kind of interacting sections or in these interfaces. So just to clarify that. And what we are doing now, we have two things that are contributing to this human-centric architecture. And one of them are these different approaches towards human-centric design. So what we did so far in the initial version of the document, and we are reiterating this document, as I will also tell in a second, we kind of positioned ourselves within all these abstract frameworks, as I mentioned before, and within all these different approaches towards the human-centric design. So on the one hand, this is kind of also sorting the field and kind of mapping the field, and then just adjusting a position for ourselves within the project. But what's also going in there is the technical architecture. So namely, diagrams that show the interrelation of different components, but also some kind of models and so on and so forth. But what we're not doing is having chapter A, that is the social science part where we come from EUE, and having chapter B containing the technical architecture. But what we try to do is to actually integrate these two and to actually apply all these things that we are writing abstractly about the frameworks concretely within the technological part. So this is kind of the work where we try to get the bridge that I meant to bridge the gap, sorry, that I mentioned in the beginning. So how are we doing this? Again, there's this issue, and what we do is this human-centric architecture. We have 3 iterations of this document. The first one is already done, and the second one we are currently working on, trying to make it more concrete and trying to actually solve also issues that we identified in the first version of the document. And so the underlying assumption is that processes of technology production are actually always value driven. And in order to be responsible and in order to ensure this kind of human-centric design, it's necessary to make these values explicit. This is exactly what we're doing within this human-centric architecture, by also providing like an extensive explanation why we choose specific frameworks, for example, and also by being transparent about how we apply them. And this is how we want to achieve this responsible human-centric AI. We have also, or I have also brought the success criteria that we defined in the beginning for our approach, because it might also give you some kind of sense of what we are aiming at. We want, as I just said, all technology development processes are somehow value-driven, make these deliberations explicit. So we need an enabler within our approach to actually have these debates. We want to actually improve the processes. So it's not just defining kind of criteria or terms, but actually do something that can be seen afterwards. We also want to enable reflections of potential biases. And also it was mentioned before with the multiplicity, different perspectives of the people involved. We also want to connect to broader discussions in the field. And I think this is generally true for scientists, that they try to open up debates, but also to follow debates and to relate themselves to debates. And we want to also be concrete, like this is really what we're trying to aim at, and offer tangible instructions also for the other actors working in the system project, because there are already always questions occurring of, yeah, you're talking about this responsibility, but what does this mean, for example, for me as an engineer, or for example, for me as a project manager? And we want together with those people to actually offer these tangible instructions. We also want to make sure that when we talk about AI in manufacturing, we also talk about manufacturing and not just about AI. So I think, or we believe in the context in which you apply AI also matters in relation to what this means for responsible development. And also what we want to do, we want to function as a blueprint for others. So we want that our work is adoptable for other projects and therefore is also meaningful in the sense of further collaborations. So I was talking a lot about or foreshadowing about these R principles already. And what they basically are within this whole field of human-centric architecture and human-centric design, one specific attempt to translate rather abstract dimensions from the frameworks into very concrete steps. And I don't want to go too much into detail. I just want to mention that there are these 3 principles, namely accountability, that is mostly addressing also that the system needs to be held accountable in relation to the humans. It needs to be explainable how decisions actually came to be, or the system needs to be responsible for the decisions it took. While this responsibility term is rather understood in the terms of liability. So also it links to people. So who did what, who is delegating which decisions to the system. And transparency also means that actually some kind of reproducibility of decisions, and this kind of precondition also to determine responsibilities and to hold the system and the people accountable. And what we did with these principles, we identified them, and I won't go into detail why we choose specifically them, because this alone would take probably about 50 minutes. But what we then did is, and this is now like kind of the real work that we are trying to do, to actually map these abstract principles to the concrete project. So for example, when we take responsibility, again, it refers to the role of people themselves in their relation to AI systems. And in the presentation before, we have also seen this people pointing fingers at others and this nice picture with the egg. So where is the problem? And what we see is that there is some kind of also responsibility or delegation of responsibility when we negotiate, for example, which component is responsible for what, or what is the function of a specific component. Shall the ensurement of GDPR compliance rely rather in the data fabric, or is this something that the components using the data fabric need to ensure in the first place? So there is this kind of delegation, multiple people are involved. So where exactly do you pinpoint the responsibility? Who exactly is responsible in the end? And so what we propose, for example, is this kind of responsibility map. And we're currently planning also for the second iteration of this human-centric architecture to facilitate concrete workshops where we also want to include reflections about the methodologies that we are using within this workshop, for example, moderation tools and so on and so forth, also to be accessible for others, that actually make it, as we told them before, explicit who is responsible for what. What does this mean for these specific components, but what does a responsibility for in another component also mean for my component? And these are the next concrete steps that we're trying to do. I hope that this example gives you somehow an impression of what we are aiming at. And what this also means, what you can see here, is there is a need for the development of new methods and workshops that actually produce then these inputs for the human-centric architecture that is supposed to kind of gather and bring together all these different approaches within the Assistant project. I promised you also some reflections. These are kind of preliminary insights that we're also having thinking about our own work. So what we actually realized also, we are not applying some frameworks here, but we're actually contributing to develop them and to make them more concrete. So it's not that we are using the art principles or human-centric design in general kind of off the shelf and just applying it in the project, but it's actually about finding out what are we actually doing, how do we actually do that. And I also mentioned that seconds ago, that we also try to make this explicitly in the sense that we provide this also then to others, the experience that we're having. We also have the reflection that it's sometimes hard to find which questions to ask at which level. I in the beginning showed you also these different approaches looking at the result and the process. It's not always hard to separate that. And it's also, when you talk about responsibility and specific components, it's sometimes hard to determine at which kind of level do you have to actually have that discussion. So how deep have you to go down, or do you have to go down in the technicalities? How deep do you want to go into specific models? This is kind of also an interesting thing that we're trying to play with. Also in these different, in these various iterations of the document. And also something that we are concerned also with at the moment is actually this synchronization of requirements and the human-centric design, and what the right moment for intervention is. And when we say intervention, we don't mean something like we as the ethics people going to engineering people saying there's something going wrong, we have to intervene here. But what we rather want to say with intervention is to actually have these kind of workshops to collaboratively think about, for example, this responsibility map. But what we face here is that also as a first step within the project management logic, all these requirements documents were defined, but these requirements documents already contain a lot of decisions actually made. So there is a lot of also responsibility related or responsibility affecting work already going into these requirements documents, and they are now also fixed and published and part of deliverables that are actually handed in also within the EU project. But on the other hand, so they are on the one hand the starting point, so we have something concrete at hand that we can talk about and we can reflect upon. But on the other hand, they also have decisions in them, and this kind of synchronization is also something that we're currently thinking about. How can we determine right moments for intervention where we might not have the full overview of what is planned in terms of requirements, but it's still like, when is it still flexible enough, and all these kind of questions. And obviously, I think I don't not need to elaborate on that. The COVID situation and the difficulty of in-person meetings, especially in this context where we do kind of pioneering work and where we actually try to work with people, is somehow also something that we experience as a challenge. But as I said, this is probably true for all of you, and so I won't go into detail for that. So I hope that I could give you some impressions and that you could follow kind of the story that we're trying to tell in relation to making things or translating things from abstract frameworks into concrete applications, and these different steps that we made from this architecture, identifying issues we want to solve, and now working on workshops. And we're also happy to stay in contact to also then inform you about concrete outcomes and, for example, concrete results of the workshops or concrete experiences of the workshop. And I have seen that there are also many representatives of our partners here. So if somebody wants to add something, feel free to, and otherwise I'm happy to take any questions or also feedback that you might have. Thank you very much.
Thank you very much, Benedict. I don't know if there are any questions in the chat. In the meantime, I would like to inform you that we will be sharing the recording, right, with all the projects, also in the cluster page, but also with other projects, so that you can, share it with your contacts, with your channels, because I think this is also a very good, interesting discussion to see what each project is doing and what are the different approaches. So yeah, having said that, I think we can jump to the presentation of the Koala project by Professor Castells. And I'll take also the opportunity to say that she's from Canada. So we started, with a presentation, from somebody who resides in Japan at least, and gave this perspective. I don't know if we are going to see something similar for Canada and North America in this presentation, but I'm anyway looking forward to it. So please, Celine, feel free to introduce yourself, your project, and deliver the presentation. Thank you very much.
Thank you, John. I'm very glad to be here. I'm gonna present this Koala project very, very quickly because I have to leave at 4 and I don't want to be out of time. I try to, yes, okay. This project is led by different partners, as you can see in this slide. And Canada is not involved in this project. I'm a law professor at the University of Ottawa in Canada, but I'm also a shareholder at Anity in Toulouse. So this is a French part of my activity. And as you can see in this slide, there are 5 countries which are involved in this project. And Koala is basically a chatbot in the industry. And Koala means cognitive assisted agile manufacturing for labor force supported by trustworthy AI. And the goal of this project is to develop a human-centered AI-based digital assistant to optimize manufacturing quality and training. We try to provide a more proactive approach to support situations characterized by cognitive load, time pressure, and little or zero tolerance for quality issues. And I think the second part is most interesting for us. We also try to support workers that need to use analytics tools and new workers that perform on the job training. The training part is a very important part of this project. Koala's AI-focused education and training concept will prepare the human side of the collaboration, and our goal is to have a better knowledge about the interaction between human and machine, and by offering concept for teaching professionals systematically and in the language of the workers about the capabilities, about the risk and limitation of AI in manufacturing. And And the solution we propose is to using analytics tools and new workers that perform on the job training. And our more broadly goal is to have highlights on education and training concepts that focuses on building blue-collar worker competencies in human-AI collaboration. Very quickly, I just want to talk about the objectives 3 and 4 because that is the part which is more related to ethical and legal issues because it's a human-AI collaboration part of this project regarding barriers and skepticism in the use of voices, AI voice by the digital assistant in manufacturing environments. And also the other part is about improving the competencies of blue-collar workers and the risk in the shop floor. In this consortium, in this partnership, we have built 3 different cases, and the first one is the most important regarding the human-AI interaction. This cases is about textile production, and in this industry, we have a specific issue because the workers are very specific workers, and they're old, and there is a need for training new workers, and there is an opportunity here to better understand how to help them to train the new workers, and also how to answer to a specific question and how to solve specific questions. And in this context, we have seen several ethical and legal issues, and I'm going to present both. Regarding legal issues, we can consider gender bias, trust issue, and balance of power as well. I don't want to consider privacy here in this presentation because privacy issues are governed by the GDPR. And in this project, we also have a DPO, data protection officer, who takes into account privacy issues, of course. And it's not a part of the research in itself. It's just a part of managing, a part of the management of this project. So regarding gender bias, we can ask the question because most of the workers are men, and because there is a need to collect some data from them, we can ask, the first question we can ask is to know if there is a gender bias, a gender issue in this process. But finally, we consider that there is no impact in this specific project because user profiles are not important regarding the training, and we already have concluded that user profiles should not be classified in terms of gender aspects, and we don't have to consider gender aspects. Second, we also consider that our future ethical and legal recommendation should not be adapted, and there is no need to build and to set specific AI regarding the gender. Specifically because it's a chatbot and there is a voice recording and a voice training, there is no need to adapt this digital assistant regarding the gender and there is no issue regarding the tones and other aspects of the voice settings. So finally, if one can ask the question of gender bias at the first glance of this project, finally there is no specific issue on it. The second question is about trust, because we think we could have several problems here regarding trustworthy interaction between human and AI, between a human operator and the chatbots, and all scenarios, all the scenarios of production are involved here, are concerned. The first point is about the feeling of continuous recording. If the worker thinks that his voice or video is all the time, during all the day, recorded by the system, maybe there would be a mistrust with this aspect. Second, there is a lack, there could be a lack of fluidity in the conversation, because it's important that the chatbot could answer the question, the specific question, and could analyze the problems, technical problems of workers, of course. And if there is a misunderstanding, or if the answer of the chatbot is vague or not relevant, of course, there would be a lack of fluidity and mistrust as well. We could have also a lack of effectiveness. For instance, if the recommendation is not relevant, if it's inadequate, or if the answer of the system is not good enough, if the quality of risk assessment and the quality of the answer is not good enough regarding the problem, at the end of the day, it would be unuseful. The third point is about the lack of emotion and authenticity. We think that the workers need to be engaged with the system, and if the system is friendliness, if there is no interaction, no interaction such as human interaction, something specific and personal, if there is a lack of emotion, probably the worker won't be very involved in this system, and probably it can be boring for them, and probably we could have a lack of engagement and involvement of the workers. And finally, we can also have a lack of mutual trust if the system asks too many questions, ask confirmations, repetition, and to say it again, and to have several times the same process. We could have a mistrust from the workers as well. So it means the system has to be very well designed, and we still try to think about the better way to do that, because the trust part, the social acceptability and the trust part is very important and very difficult to consider. And finally, we could have a problem with the balance of power. Just to sum up, the problem here could be a lack of autonomy or freedom of the worker. And we think it's very important to have a certain level of autonomy, of course, and to think about the human control and what the human can do in the use of the system, and not to be and not to obey all the time to the recommendation of the system, because we think we could have a mistrust in this situation as well. And we could also have a problem with depending on the age or the social background of the workers. The interaction with the chatbot could be different, and in the interactive process, we could have a problem of accuracy if the answer, if the interaction is not, if the quality of the interaction is not good, we could have some accuracy problems in indeed iterative process and during the cycle of using this system. That is for this part is for the legal the ethical issues. Regarding the legal part, if we consider the European Commission proposal, the AI Act, which has been published in April 2021. We can consider that a chatbot, which could be a very simple system, is in the scope of this proposal because the scope is very broad, and it's an AI system regarding this definition. And the question is to ask what kind of risk, because this proposal is a risk-based approach. What qualification should we give to this kind of system? Obviously, it's not an unacceptable risk because, as you can see on this slide, we have 4 categories of unacceptable risk, and the chatbots in a manufacturing system is not concerned is not in this scope of unacceptable risk. We can ask if it could be a high-risk AI system. If we consider the Annex 3, which listed the domain and the sector which are concerned by this qualification. And finally, even if we have a process, even if our system is based on education and vocational training, that's not exactly the case which are in this AI Act. And finally, there is no link between this annex and our system. So finally, our system is not a high-risk AI system. So we think the system we create, we built currently could generate only limited risk, and based on Article 52, we just have to respect a transparency obligation regarding the fact that the worker, the human, has to know that he or she interacts with an AI system. And in our circumstances, it's obvious because that is the specific goal of the project. So we do not have any specific transparency or information obligation because it's already the case. So finally, we can say that we have only one very simple legal requirements, but we have many ethical issues to consider, and especially the need for human control and the need for accuracy and to have a good quality of interaction to preserve this good quality. Thank you very much for your attention.
Thank you very much. That was quick, but a lot of content, right? Really. So, okay. So I think, that was really fast presentation, but with really a lot of content. So I think, we are just in time. Well, 5 minutes over time. I'd like to thank all the speakers for being with us today. I would like to thank the audience for sticking, although not, being easy asking questions like you did probably in the previous workshop. What I want to say is that we have recorded the seminar, so maybe Paolo will stop the recording in a while, and we will make this available also to all speakers who are registered. But